Here for example 6, I'm going to show you a little bit different problem, still a horizontal translation, but instead of just shifting left and right by a nice pretty pi over 2, we're still going to shift by a radian value, but it's not necessarily going to be a nice pretty radian value. Before we figure out really our amplitude and all of our period and our vertical translation, which there won't be one, we need to, we also need to figure out a phase shift here. What we need to do is we actually need to solve our equation. This is our b. This is bx plus c, but we need to factor the b out of this equation. So we're going to take a negative 1/2 sine of. Now we need to factor out a pi. The reason we do that is once you factor out a pi, then you can figure out what your phase shift is. So this is going to end up being x plus 1. This is the equation you need to use in order to figure out your phase shift. So if we look at our amplitude is, we have a negative. Also, we haven't done one of these with a negative yet, but our amplitude is going to be a 1/2. The negative, what's that mean? That means that there will be a reflection. Is a reflection over the x-axis. So for our S shape, instead of our S shape looking like this, it's going to end up looking like that. That's what a reflection will do. So then we find our period. Well, the period, that is just taking your b value here, this b value, taking 2 pi divided by our b, which is 2 pi over pi, which is just 2. That can't be possible. 2 radians? Uh-oh. I don't know how we do this. Vertical translation, that means, what's our d out here? We have no d. There's no d, so therefore no vertical translation. The part I forgot to type in here was the phase shift. Your phase shift is actually going to end up being a -1. Okay, we're going to actually shift 1 unit left, 1 radian, because of the negative. So what we're going to do is we are going to graph this function, and we are going to go to the left. We'll call this 1 radian. Okay, that's going to be our 1 radian. Now we're not going by pi's here, we're just going by radian values. So if that's a -1, this will be a +1, and then this will be a +2. So our normal function, we should probably, our amplitude is a 1/2 going up. That could be a 1, this can be -1/2, and this can be -1. So your graph is going to be in between a half and a -half. It's going to be between, normally it would be between 0 to 2 pi, but it's between 0 to 2. But it's also not going to have this S shape going up and down like this. It's actually going to have an S shape going down first because of your reflection, up and then over. So you have 4 things here. And then we're going to take this graph that's going to be shifted, it's going to be graphed, down, what's that thing? It's going to be normally an S shape where you start up. This graph instead is going to be going down like this, up, like that, and down like that. What we're going to do is we're going to take this graph, we're going to shift it to the left 1 whole radian value. So we're going to start at -1, and you still have your 5 points. You're going to go distance up, the period is 2, so you're going to go over here to 1. There's your end point, halfway in the middle. And then instead of going up a half first, because of the reflection, you're going to go down a half, and then you're going to go up over here. So we sketch this in. We're going down, going up. Here, my friends, is a graph of y equals -1/2 sine of pi times x plus pi. So it's a lot. It looks a lot worse than what it is. You need to break it down. You need to list any of these 4 things that you may have, and then just I always try to start with, use a couple of these, throw in, maybe sketch a little dash graph, and then shift it. I always do my phase shift last, and that's what I'd recommend doing for you guys. So that's example 6. Booyah!